Okay, now you can see chapter 12, PowerPoint. Okay. Chapter 12 is about inventory management. When we say inventory, the stock of any item or resource used in an organization, manufacturing company need materials and so on. And service business, they need supplies and so on like that. When we say manufacturing inventory, then raw materials such as wood, iron, rubber, plastic, and so on. And then components such as engine part and so on like that. And then in abbreviation, MRO, maintenance, repair, and operating supplies. Like, you know, our department has a copy machine, then like a paper, ink cartridge, and so on like that. Those are kind of supplies. So to maintain and repair and then operate something, we need supplies. So supplies, or we can call MRO. And then in middle of the process, working process, like a component and not finished product, and then finished product, they are manufacturing inventory. And the objective of inventory management is to strike a balance between inventory, investment, and customer service. Okay. Too many inventory, that means cost. Too less inventory. Sometimes there is demand, but out of stock. That case, if we have inventory, then we can sell, but because out of stock, we cannot sell. There is opportunity, but we cannot sell. So less inventory than demand. That is kind of, that case, we can say there is an opportunity cost. So we need meet the demand for the optimal inventory level to meet demand, not too many, not too less. Function of inventory, maintaining independence of operations. If, go back to, if a schedule, production schedule is A and B, A, B types like this, then if they use one production line, then A come, B come, C come, and so on like that. But if enough inventory of B, then we can change the schedule like A, B, B like this. So each product inventory enough, then we can maintain independence of each types of products. And to meet variation in product demand, if we have inventory, enough inventory, then demand surge, then anyway we can sell. Then to allow it flexibility, the same, if the demand change, then if we have enough inventory for certain product, then independent each product. To provide a safeguard, the same story, if there is a safeguard inventory, then in case demand increase, then we can meet that increasing demand. To take advantage of economic purchase order size, if we have enough inventory space, then we can buy as many as part or component. Then if we buy more, then sometimes we can get discount. So buy more, then we can get economic purchase order, discount order. And the inventory cost, holding cost, setup cost, ordering cost, and strategic cost. Holding cost, if we have inventory, then we may need space and employee and electricity and so on. So holding cost, such as handling, insurance, and so on. And setup cost, when we order, setup cost is like a produce different types, then we need to set up time, and then we need employee and so on. So set up time to make a different product, and order cost, when we order, then like a shipping cost and so on. And then strategic cost, if there is not enough inventory, then demand, then the opportunity, we can sell, but out of stock, so we cannot sell. So strategic cost is opportunity cost. Managing inventory, when we manage inventory, many companies use this ABC analysis. ABC analysis is divide inventory into 3 categories. Class A, Class B, Class C. Class E is the most important product inventory. Based on the annual dollar value, if annual dollar value is high, it's like that in automobile company, like an engine, the value is high. And then like a door panel, the instrument panel, and so on like that, they value is kind of middle. And then like a nut and bolts, their value is low. So based on their value, classify class A, B, C, and then also the kind of volume. A, not the dollar value is high, but the amount is not many, because each value is high. So the inventory, number of inventory is not many. So 15%, class B 30%, and then class C 55 and more percent. So certain companies, by this criteria, we can divide inventory in 3. Type A, class A, the value is high, dollar value is high, but inventory size is not many, like 15%. If the total is 100%, then B item or class B, dollar amount or value is in the middle, and then the amount, the size of inventory, also medium. And then C, class C, the value is low, but the inventory size is large. So A, B, C like this. There are certain companies classification, item number like this, then the percentage of number of items stocked, the size of inventory 20%, 30%, and 50%, and then amount, the value 72%, 23%, and 5%. Class A, B, C, like this. So that means when we manage inventory, type A, class A, carefully manage, and then next and next like this. Then cycle counting, accounting reconciliation of inventory with the inventory record. So sometimes there is difference in the record, in the inventory record, and then the real inventory size are different. So continuously check inventory, the record, and match the inventory record and real inventory. Use inventory classification, class A, B, and C, because class A is important inventory, so count frequently, like once a month or once a week, like frequently. And then class B, less frequently, like every quarter, once a quarter. And then class C, not often, maybe every 6 months, and count the inventory to match and so on. And then item counted, if there is difference, like inaccurate accurate number of between record and then real inventory, then documented like this. So when we manage inventory, we can use this cycle counting and then classification ABCs. That is ABC analysis and cycle counting. Next, inventory system. Inventory system is such as ordering system. So we need an inventory to meet demand. So if we forecast the demand size, then to meet demand, we order then many. So inventory system is kind of ordering system. There are two types of inventory system: single period inventory system and multi-period inventory system. Single period inventory system, just a one-time purchasing decision, decide order size, and then order that many, and then forget it. Next time, decide again, and then order that many, that order size, and then forget it. Next time, again and again. So don't use the same order size. So the item will not be reordered. Next time, decide again and again like this. Multi-period inventory system, the decision involves an item that will be purchased periodically, where inventory should be kept in stock to be used on demand, and then order size, decide and then use that order size again and again during a multi-period. And then there are two types of multi-period ordering system, inventory system. First one, a fixed order quantity model, and the second one is fixed time period model. Fixed order quantity model, fixed order size, and then that order use again and again. So we call this fixed order quantity model, as other name is the economy order quantity model, EOQ model, or Q model, because we fix order quantity, so Q model. And then fixed time period model, fix the term, like every week, every 10 days, every 30 days. So time come and then place order and so on. So we call this one as the periodic system, periodic review system, fixed order interval system, or P model, because we fix period. And then this EOQ model or Q model is event triggered model. I will tell why it is event trigger model later. And then this one time trigger model. Fixed order quantity models determine the specific point, reorder point. R is reorder point. Our textbook denote this reorder point as ROD, ROP, reorder point, but I denote just R, reorder point. And the size of order size Q. So using this model, we decide when we place order and what is the order amount, quantity. Bayesian model assumptions. Demand for the product is constant and uniform. If demand, we order Q and then receive Q, then initial inventory level is here. Then if demand is constant and uniform, then this inventory level line is straight like this, linear. And then lead time is constant. Lead time is time between order and receive, like a delivery time. For this model, Bayesian model, constant every time the same, like 5 days, next time the same, 5 days and so on. And then price per unit is the same. And the inventory holding cost is based on average inventory. During this period or term, from level of Q inventory and then 0, during this term, average inventory is half of Q. So Q divided by 2, that is average inventory. And inventory holding cost is based on average inventory. And then ordering or setup costs are constant, not the same every time. And all demand for product will be satisfied. That means during the term period, the average inventory consumed completely, and then next time order, receive, and so on like this. And then this Q model earlier, event triggered model. So event in this model is point R, reorder point. Because of a lead time, before out of stock, we should receive that order. So place order this early. So when this inventory level hit this point R, reorder point, and then trigger the placing order. So R, reorder point is event. So this model is event triggered model. Here are total cost, annual cost equation. Annual cost equals annual purchase cost plus ordering cost and holding cost. Annual purchase cost is annual demand, uppercase D, times item cost, cost per unit, and plus ordering cost, annual demand divided by order quantity. If annual demand is 1,000, then order quantity D equals 1,000. Order quantity is like 100. Then annual demand divided by order quantity equals 1,000 divided by 100, then 10. 10 means to satisfy annual demand when order quantity is 100, to satisfy this annual demand, place order 10 times. So the number of order times ordering cost S, that is annual ordering cost. And then annual holding cost. Earlier, holding cost based on average inventory level. So if Q is order quantity, then divided by 2 is average inventory level times holding cost. So this is annual holding cost. So earlier when we talk about capacity, then increase volume, then decrease unit cost, and then increase again. Total cost is the same. So if we increase order quantity, volume, then total cost decrease, but sometimes it increase again. On this point, slope, this curve's slope decrease, 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 and then on this point, the slope of this curve is 0. So using derivative, then equals 0, then we can get this formula. Order quantity formula, economic order quantity, or we can call this one as optimal order quantity. So Q optimal like this equals square root of 2 times annual demand times order cost divided by holding cost per unit. And then reorder point R equals daily demand or average demand, then times lead time. This daily demand or average demand, if that store or plant open 365 days, then if annual demand is D, then daily demand or average demand is D, uppercase D, So this one, daily demand, not P, doesn't work again. D, uppercase D, annual demand divided by 365. Or if the store or plant open like 200 days, then to get daily demand or average demand, then use this how many days open or how many days no work. So example, annual demand 2000, so this one is the uppercase D. The holding cost $2.50, and then cost per unit is $15. Ordering cost is now $10 per order, and lead time is 7 days. Order quantity, square root times 2 times the annual demand times the order cost divided by holding cost. So plug in 2 times 2000 times 10 divided by 2.5 equals 126.49. For this, always round up. Even 126.1 still round up, and 127. Then reorder point, daily demand or average demand, 2000 annual demand divided by 365 times 7 lead time equals 5.4794 times 7, 38.36. So this one also round up 39. And then cost, total cost, annual total cost equals annual purchasing cost, annual order cost, annual inventory or holding cost. So plug in 2000 annual demand the times unit cost is annual purchasing cost plus placing order. So annual demand divided by order quantity times $10 order cost. So this one is annual order cost plus annual holding cost, average inventory. So Q divided by 2, average holding cost, average inventory level times holding cost 2.5. So like go back to the graph here. Point is right. Then this blue line is annual holding costs. Increase order quantity, then holding cost increase, but order cost decrease. On this point, if this quantity is optimal or economic order, holding cost and ordering cost the same. But here, order rounded up order quantity. If I use this for order quantity, then they should be annual total cost is 30,316.23. But the Bayesian model has problem because demand is not constant, sometimes more, sometimes less. So we need safety stock in real world. It looks like this. If demand is constant, then we can predict when the inventory level is 0, then place an order sometimes in point R. But sometimes more demand, then it can be out of stock. Earlier then we received the next order, then out of stock. So we need a safety stock. So we call this safety stock model. Safety stock model. This safety stock model and Bayesian model use the same order quantity equation. Only difference is reorder point. Difference is only reorder point. Reorder point equals the same, the Bayesian model's reorder point plus safety stock. As you can see on a graph, reorder point the same as Bayesian model plus safety stock. Safety stock equals z-score times standard deviation during lead time. And then daily demand such annual demand divided by how many days. Then this one, standard deviation during lead time equals square root of sum of this one is variance. Standard deviation square is variance from 1 to L lead time. Looks complicated, but with the example, it's not that complicated. Okay, daily demand is 60 units. Annual holding cost equals 0.5. The desired service probability or service level, 95%, 0.95. It's like that. When we go certain store, such as Walmart, not every time, but sometimes they ask me, was it finding okay, like that, right? So, yes, sometimes yes, but sometimes I want such, but out of stock, so I couldn't buy. So I tell, I want that, but there was no stock and so on. Then they call, and then if they have the back stock or something like that, then they said out of stock, and then we will back order, and then sometimes later it come. So if I go there and then 100 times, then if I can get 99 times what I want, then this store's service ability, service probability, or service level is 99%. So to increase service probability, they need more inventory. If the inventory level low, that means the order quantity is low, then service ability, service probability, service level low. So depending on service probability, order cost or order inventory level different. And the cost of placing the order cost is $10. Standard deviation is 7 units. And lead time is 6 days. So giving this service probability or level, that means this one we should use to find the order quantity. And the order quantity is the same, even a Bayesian model or a safety stock model. Reorder point are different. So when we find the reorder point, we should use safety stock model. Anyway, order quantity is the same, whatever the Bayesian model or safety stock model. So using the same formula, 2 times daily demand, because this one is annual demand, daily demand times 365. Because this example doesn't say, doesn't mention about how many days. So just use 365 times 10 order cost divided by holding cost. Then square root of 876,000 equals approximately round up, and then 36 units order quantity. Then reorder point. To get a reorder point in safety stock model, we need standard deviation during lead time. Formula looks like, so square root, this is standard deviation 7, and square, so this is the variance. Sum of from 1 to L, so add L many, L is 6, so 1, 2, 3, 4, 5, 6. So 6 times L, 6 times standard deviation square, and then square root, that is 17.15. And then we need z-score. Z-score is about this service probability associated with this one. Excuse me. From a normal distribution table chart, try to find the service ability or probability 0.95, 95%. 95%, you cannot find the exact 95%. That case, find nearest. 0.95 is between 0.945 and 0.95.53. This one is nearest to 0.95. So take this one, and then z-score is 1.65. So plug in 1.65 here for G-score. About this now 0.95 service probability. And then daily demand is given 60 times 6 lead time plus Z-score 1.65 times 17.15 standard deviation during lead time. So approximately 389 units. So inventory level drop and then hit that point 389, then place order and so on. Place order this many. Question? Okay, good. Okay, about 10 minutes more. So without break time, just keep going. That's okay? Okay. Next one is now fixed time period model. So fixed time or reorder time T. So time comes and then place order. So difference between fixed time period model or Q model. Q model fixed order quantity. So every time when place order quantity is the same. But order period difference. This fixed time period model, the time fixed. So time is the same, the period the same, but order quantity may be different because demand is not constant. Sometimes there is inventory on hand, many, sometimes less, and so on. So this P model also kind of safety stock model. So using safety stock like this. So order quantity, when we use P model, then average demand over the vulnerable period. So daily demand times time fixed, like every 30 days, every 7 days, like that, plus lead time, plus safety stock. This one, Q models safety stock is during lead time, but this one plus T. So standard deviation during the term plus lead time, and then minus if there is inventory on hand, then subtract that many. Example, daily demand is 10 units, lead time is 14 days, and then 150 units on hand, standard deviation is 3, and desired service probability is 98%. The review period T equals 30 days. We need standard deviation during term plus lead time equals the same term 30 days, every 30 days, plus lead time is 14 times 3 standard deviation square, and then square root 19.9. Q equals such, and then we need a Z-score about 98% service probability. So 98% is between 0.97982, 0.98214. Nearest or closest to 0.98 is this one, 0.979. So this score is 2.05, 2.05. So plug in, or daily demand is 10 times the period is 30, lead time is 14, plus 2.05 z-score, and then standard deviation during T plus L is 19.9, then minus inventory on hand 150, so approximately 331. Question? Okay, I think that's all. And go back to today lecture is relatively short. You have assignment channel, chapter 12. Click this one. Then you have a question. I will open this one. Okay, change. Looks like this. Now 4 questions. So find an EOQ, the order quantity. So using a Q model. Then annual holding cost, annual ordering cost. Then if the service probability is 99%, that is 1% less than 1% risk during stock out of stock. That is 99% service probability. So using safety stock model, find the reorder point, ROP. And due date is next Monday, midnight next Monday, that is September 21st. Okay. I think it's doable. Just find what number you need to plug in. Okay. So if you have a question, then email me. Then if you need to meet me individually, then I will set up the Zoom meeting individually. Then I will go over again. Okay.
Sounds good.
Okay. Short, but that's all. Okay, thank you.
All right, thank you.
Have a good night.
Thank you. Good night.
Night.